So last section we're going to look at this week is 3.7, and that's on graphing absolute value functions. It's going to be the same kind of thing we did in 3.6, except the shape is a little different. We're also not going to go quite into as much depth like with the horizontal stretches, so we're not going to do quite as many. We're going to stick to some of the simpler ones that we did, like shift up, shift down, shift left, shift right. So we're going to focus in on just those. Does anybody remember what the symbol looks like for absolute value? Yeah. 2 bars. Yeah. 2 vertical bars. So the first thing on your guided notes, it says and then there's a blank. So an absolute value function is a function that contains an absolute value expression. Okay, so how do you know if you have an absolute value expression? Exactly what Abby just said. You're going to see 2 bars, something like this. That's an absolute value expression. Set it equal to y. Now you have an absolute value equation or function. Now, from what we did in the last section, I'm going to bet some people could already figure out what this plus 2 is going to do. It's kind of like in the last section when we had a plus 2 inside the parentheses. Except now we don't have parentheses, we have bars. So what does a plus 2 do if it's inside something? Can somebody look at the chart and tell me what that does? It's not a plus 2 at the end, it's a plus 2 inside. On your sheet, it would be inside the parentheses. Yeah?
Horizontal shift left.
Yep, exactly. And that's exactly what this plus 2 would do. It would shift the graph left 2. So all the transformations that we learned in the last section are going to work exactly the same in this one. There's no difference. So when I say shift left 2, like, well, shift left from what? Shift left 2 from this one. So what I just put a box around, that's called the simplest absolute value function you could have. It doesn't have a plus or a minus. It doesn't have any other numbers. It's just 2 bars with an x. And the name of the simplest absolute value function is called the parent function. The reason they call it parent is because if you think of it like your parents, you come from your parents. Well, this comes from this somehow. It's a little bit different. Like, you're different than your parents, but it's based on this one. You modify it somehow. Maybe you put a plus 2 inside. Maybe you put a minus 2 on the outside. But this is the most basic one that we could have. And that's called the parent function. So an absolute value function is a little bit different the way it looks than a line. It's not a line. An absolute value function looks more like a V shape. And you guys should have a picture of that printed on your guided notes. So it's like all of a sudden the V shape causes it to change directions. That point where the V shape changes direction, where the point is, that's called a vertex. So that's the vertex of my V shape. Now, we've talked about these 2 terms before, domain and range. We haven't talked about them in a little bit, so let's just kind of refresh what they mean. Domain has to do with x's. Range has something to do with the y's. When you want to know what the domain is, you look at your graph and you ask yourself how far left and right the V shape goes. So if we look at that V shape, and imagine you could keep looking at it forever. Like these two lines, they don't stop there. They keep going. So if they keep going forever, how far left and right will this V shape go? If you could like imagine zooming out and looking at it forever. Yep.
Infinity.
Infinity, right? This V shape is never going to stop going left and right. This piece just keeps going to the left. It also goes up. And this other piece goes to the right and it goes up. So when we want to know what the domain is of an absolute value function, every one of them has the same domain. They're all this. All real numbers. Every single absolute value function will go to the left and to the right forever. I don't care if you shift it up, something like that. That still goes left and right forever. If you shift it down and make it skinny, it's still going to go left and right forever. It's going to go left and right a little slower, but it's still going to go left and right. Even if you took an absolute value function and flipped it, if you flip it over, it's still going to go left and right forever. Still heading in those two directions. All right, now let's look at the range. Does this V shape go up and down forever? Anything, Abby? No, it does not go up and down forever. Which way does it go? It does do one of them. Does it go up forever? Or does it go down forever? Yeah? It's going down forever? So you see like there's like a picture down here somewhere? It's going down that way forever? No, which way is it going? It's going up. Right? The higher and higher you look, you're still going to see your V shape. It goes up forever. So if it goes up forever, then that means it only goes down to a certain point and then it must stop. Otherwise, we would have said it goes down forever, but it doesn't. What does it look like the lowest this graph goes is? If you look at it, what's the lowest that it goes before it doesn't go down anymore? Yep. The origin, what number is that at? 0. So for this particular graph, the range is every number from 0 and up. That's the range. It doesn't go below 0. So the range is all numbers from 0 and up. The domain never changes, but the range could. For example, if you shifted it down like this, well, now the range isn't from 0 and up. The range would be from negative 1, 2, 3, 4, 5. Negative 5. And up. So if you shift it, we may have to check what the range is. Any questions on why the range there is from 0 and up? Okay. So when we want to graph an absolute value, we're going to create a table just like we did before. But today, I'm going to be very specific about what x values I want you to pick. Okay, in the last section, you had a lot of freedom. Okay, I said you could pick anything. But in this section, we're not going to do it that way. I'm going to give you very specific numbers to use. So we're going to create a table of values. So on your guided notes, where it says graphing absolute value functions, and then there's a number 1, and a couple blank lines, that's what you're going to put on line 1. So you might have a problem, you don't have to write that down, but you might have a problem like that. Actually, even simpler. Like that. And the first step is to look at what's inside the bars. In this case, it's an x plus 4. And you're going to set that equal to 0. Actually, we'll do a problem right now as we go through the steps. The reason we're doing it this way, and I'm not just saying pick any random x values you want, is because when you graph an absolute value function, there's one thing that's very important to graph, and that's the point of the v-shape. You have to graph that point. And if you don't pick the right x values, you may not get the point on your graph. So you've got to get that vertex. And this is how you do it. Okay, so let's look at an example. M of x equals the absolute value of x minus 2. Now, this letter here can be an M, it can be an F, it can be a G. That doesn't matter. What is inside the absolute value bars? Hanukkah? X minus 2. So that's what's inside. And what does it say to set what's inside the bars equal to? Yep. Set it equal to 0. And then solve it. Okay, let's solve it. How would I solve that equation? X minus 2 equals 0. Yeah. Okay, so if we subtract 2 from both sides, what's negative 2 minus 2? That's negative 4. Oops. So we would have x minus 4, and 0 minus 2 is negative 2. So that's what happens if we subtract 2 from both sides. Yeah? Let's add the 2 instead. Okay, so add the 2. Now negative 2 plus 2 is 0. And we get x equals 2. Okay, we're going to come back to that number. But as far as picking x values to make your table, that's one of the numbers you're going to pick. You're going to pick a 2. Okay. But you need more x values. Right? Last time we did 3. This time I think we're going to do 5. Okay, we're going to do 5. Because it's a V shape, so it's a little bit more complicated than a straight line. So we need a couple more points. Well, x is going to be one of the values we pick. So what else do we want to pick? My suggestion is pick a couple that are lower, and then pick a couple that are higher. So pick the next 2 values that are smaller than 2, and pick the next 2 values that are bigger than 2. And those are the x values you're going to use. Now, it's not always going to come out to a 2. That's just this problem. So under step 2, start by writing down the value you just got, x equals 2. That's going to go in the middle. So we're going to have a table of 5 values. That's the one in the middle, 2. What's the next value that's smaller than 2? What do you think? Yeah? Before that. We're going to stick to numbers that don't have decimals. So smaller than 2, but bigger than 0. 1. What's smaller than 1? Yeah, 0. Now let's pick a couple that are bigger. Okay, remember, this was the one in the middle. Anaya, what's a number bigger than 2? 3? Caleb, bigger than 3? 4. There's your values we're going to use. So in this time, everybody in here should be using the same x values. It's not like the ones we did yesterday where some people may pick different numbers than other people. Nope. Everyone's using the same numbers today. Okay, so that's step 2. Now, once I get my x's, what do you think step 3 is? Because we're making a table, what else do we still need to do in that table? Yeah?
Find the y values.
We still need to find the y values. So step 3 is calculate the y values. How do you calculate them? You use the formula they gave you, just like we did yesterday. You're going to plug each one of these numbers into a formula, one at a time, and write down the answer. So we have 0, 1, 2, 3, 4. I'm going to scroll back up and copy down what my formula was, so that way I don't have to keep going up and down. M of x equals x minus 2. Absolute value. Right, so let's plug them in one at a time and see what we get. I'll start with 0. Brady, what's 0 minus 2? And what's the absolute value of negative 2? No, the absolute value of negative 2, it doesn't stay the same. Yeah? 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 2. Remember, the absolute value of a number is always positive. Let's try another one. Let's try 1. Emily, what's 1 minus 2? And what's the absolute value of negative 1? 1. Good. All right, let's do 2. Mia, if I plug in 2, what's 2 minus 2? 0. And what's the absolute value of 0? 0. Let's do 3. Alyssa, what's 3 minus 2?
1.
And what's the absolute value of 1? 1. And Micah, what's 4 minus 2? And what's the absolute value of 2? What did we say about absolute value? Someone remind me, yep? Yep. So, it's not the opposite. It's always positive.
Oh, okay.
2. Yeah. And look at your y values. If you notice these 2 and these 2, that is always going to happen because of the way I had you start with this middle value. You're always going to get the same one here and here, and the same one here and here. If you don't, you did something wrong. So now we've got our table. And what do you think we're going to do with all these numbers in the table? What's the last step? Yeah?
Graph.
Now we're ready to graph. So step 4 is to graph. Let's try it. So we've got the points 0, 2. We've got 1, 1. 1, 1. 2, 0. 3, 1, and 4, 2. 3, 1, 4, 2. It should always look like a V shape. I guess it could flip over if you had a negative, but there's no negative in this one, so it's our V shape. And draw 2 lines. Let's see, like that. And like that. They go on forever. So there's our V shape. All right. Now I want to describe 2 things about that. I want to know the domain, and I want to know the range. What did I say the domain is always going to be? Yeah. It's always all real numbers. Domain is how far left and right it goes. But look at these arrows. It's never going to stop. It's just going to keep going left and right forever. So domain is left and right. What's range? You don't have to tell me the exact answer, but what am I looking for in the picture? I'm not looking for the left and the right. I'm looking for... So we're looking for... What's range mean in general? So domain, we're looking how far left and right it goes. What about the range? Think of what letter did I say is connected with range? Yeah? Y. And which way does the y-axis go? Yeah?
Up and down.
Up and down. So we're looking for up to down here. When you have a V shape, it will not go up and down forever. No V shape does that. Let's look at this one. Does this V shape go up forever? Sean? Yes, it does. Does it go down forever? Alyssa? No, it doesn't go down forever. So then that means it must go down and then stop somewhere. Let's look at how far down it goes. And Michael, what did you say the lowest that this one goes is? 2. So if we said it only goes down to 2, then you're saying it stops at that line. That's at 2. But it goes below that line. How far down does it go? This one doesn't go through the origin. It's been shifted a little bit to the right. Yep. So the question, I'm looking for a single number. How far down does it go? So imagine putting a line like this and start dragging that line down. And when you're no longer on your graph, stop. And tell me how far down you went. What number are we at? Yep. 0. So this graph includes every number from 0 and, how would you say it? Caleb?
Infinity, I don't know, because it's going to keep going, so we're going to stop, right?
Keep going which way?
In both directions.
We're focusing on range. So it's going to go from 0. Yep.
0 to greater than.
Yeah, 0 and up. So it's going to go up. So every number from 0 and up. That's your range. Every number greater than or equal to 0. All right, let's do, we've got a couple more. Let's do another graph one. And then we'll do a describe on this one too. We did not describe this one. But if you wanted to describe it, it has a -2 inside. So I would look at my table from Monday. Look when you have minus a number inside. And you would see that minusing a number shifts it right. So the way you describe this one is you would say shift right 2. That's what this one does. And if you look at the V shape, that's exactly what happened. The normal V shape has the vertex right at the origin. This one doesn't. It's been shifted 2 to the right. All right, let's try this one. So it says graph the function. And then we're going to compare it. So that basically means describe what happened. Did it shift up, down, left, or right? And then I want to know the domain and the range. Well, the domain you should already know. What's the domain going to be in this problem? Yeah?
X.
Well, it has to do with the x values, but the actual answer for the domain, Tirza? All real numbers. So we already know what the domain is. So we could write all real numbers on the domain line right now if you wanted. But we'll do it in. Okay, so we want to make our table. How many points do we need in the table? Yep. We did 3 yesterday, but today we're doing a few more because the shape is more complicated than a line. Yep. We're going to do 5. The first thing we want to do is find the middle number that's going to be in our table. What does step 1 say? How do we get the middle number? We have to take something and set it equal to something. Oh, please. So what does step 1 say? We want to get that middle number in our table. No, step 1 from our steps. This would be on the front. Okay, set what's inside the absolute value bars equal to 0. Okay. What's inside the absolute value bars? In x. We're going to set that equal to 0. Is there anything we need to even solve here? No. If this had like a +1 or a +2 inside, then I'd have a little bit of work to figure it out. But there's nothing to solve here. So that is my middle value in the table. Let's make our table. So the middle value is going to be 0. What's the next one we're going to use that's smaller? Yep. We're going to do -1. What's the next one we're going to use that's smaller? Yep.
-2.
-2. Now let's go bigger. Bigger than 0? Yep. 1. And bigger than 1? Yep. 2. So there's your x values. Okay. We got all the x's. What do we have to find now? We want to graph it, but we don't have enough information yet. Yeah? We need to find the y's. So we're going to fill each one of these numbers in, one at a time for x, and find each y value. So the way you do it is you're going to take the absolute value of your number and then add 3. That's the pattern. What's the absolute value of -2? Yep. Absolute value of -2 is 2. And then +3. 5. So there's our first one. Next one, -1. What's the absolute value of -1? Yep. When we do absolute value, because absolute value needs to make it positive. Yeah. Yep. So what's the absolute value of -1? Yep. 1 plus 3. 4. 0. Okay. What's the absolute value of 0?
3. Wait, no, 0, and then it's 3.
And then add 3 and you get 3. Yep. Let's do 1. What's the absolute value of 1?
1.
1, and then plus 3?
4.
4. and now 2. What's the absolute value of 2? Yeah. Plus 3?
Oh,
5. And there's that pattern I talked about before, where these two numbers match and those two numbers match. If you follow the method that I'm giving you, that will always happen. Okay, so now we've got our table. Joe, what do I do with all the coordinates in this table?
Don't put it on graph.
Yep, I'm going to put it on the graph. So -2, 5. So left 2, up 5. Left 1, up 4. 0, 3. And from here, it's going to be a mirror image of the other 2 points because the y's are the same. So 1, 4 is going to be right there. And 2, 5 is going to be right there. Draw your V shape. Just like that. Now, if you draw a good sketch, you should be able to already see what happened here. Think about where the V shape would normally be and where it is now. Yep. Yep. Okay, so compare the graph. So what I'm looking at now to do the compare is I want you to tell me what this what that +3 is doing. So look on your chart for Monday, and this is adding a number on the outside. And you've got a picture to look at too. So what does adding a number at the end do? Yeah? Yep. So we're going to say, let's see. Let's write it right here. The graph has been shifted up. We're going to say a little bit more. How much? How much did it move up? Yep. 3 units because of the +3. Normally it would be at the origin. 1, 2, 3. Move the V up 3. So the graph has been shifted up 3 units. Okay, domain. We already talked about that. What about my range? What's my range in this one? Yep. Greater than or equal. Yep. So it's anything from the number 3 and up. It never goes down in this area. It doesn't go below the number 3. Okay, so it's everything from 3 and up. And what letter do we use to describe range? Is that X or Y? Y. So any number greater than or equal to 3. And that's pretty much what this whole section is like. Just a couple more of these, but that's it. Any question on that? Right, let's try one more together. I don't know how much time we'll have to have you do one on your own today, but we have all day tomorrow, so. All right, let's do this one. So it says to graph each function. We don't have to graph each one. All I want to see is the final one. Don't worry about the original. So graph the function, compare the graph, and then describe the domain and the range. Well, again, what's the domain? All real numbers. We could write that down right now. As far as the range, let's wait on that. Let's do our picture first, and then we can see the range after we do the picture. Okay. So what's our first step to making the graph? We need to make something else first. Yeah? Gotta make a table. How many values are going to be in the table? Yeah, we're going to do 5. We're going to find the middle one first, and then we'll do 2 lower, and then 2 higher. All right, how do we find the middle one? We're supposed to take something and set it equal to something. Someone remind me one more time. What do we take and what do we set it equal to? Yep. Yep. Take what's inside the bars. It's not always going to be just an x. Like this one's a little bit different. This is an x plus 2. But in this case, it is just an x again. So take what's inside the bars, set it equal to 0, and now you're supposed to solve it. Well, there's nothing to solve. If it's just an x inside the bars, you're done. So my middle x value is 0. What's going to be my next smaller? Yep. -1. Next smaller one from that? Yep. -2. Bigger than 0? Yep. 1. And the next one bigger than that? Yep. 2. Plug them all in, one at a time, and get the y value. So this time, you're going to take the absolute value of your number and then -1 from it. So how about Anaya, what's the absolute value of -2? 2, and then -1. 1. Okay. Caleb, what's the absolute value of -1?
1.
And then -1?
0.
Good. Brady, what's the absolute value of 0? -1? Good. -1. Natalie, what's the absolute value of 1?
1.
-1?
0.
0. And we already know the last one is going to be what based on our pattern? 1. It's going to be the same as the first one. These two match, these two match. If you do it the way I'm showing. Okay. Emily, what do we do with these points now? We graph them. So -2, 1. -1, 0. 0, -1. 1, 0, and 2, 1. So 1, 0, 2, 1. That's how your V shape should look. Nice like that. And good enough, like that. All right, so we still have to do the compare. We want to describe what happened to that graph. I want to know what this -1 did. What does subtracting a number on the outside do? Not on the inside. We're gonna do another one on the inside in a minute. That'll probably be our last one. But what does subtracting a number on the end do? Yep. Shift down. And how many did it shift down? Yep, exactly. So we're gonna write the graph was shifted down 1 unit. That's how it compares to the original. We didn't graph the original, but if we did, it would have moved down 1 unit. Okay, domain we already have. Now my range. How far up and down does this graph go? Yeah. -1 and higher. So the lowest that it goes is -1. The highest that it goes, it just keeps going. So it's every number from -1 and up. And what letter do we use to describe range? Yeah? Y. So y is greater than or equal to -1. All right, so I don't think we'll get through example 3A and B. I think we'll just try to do A, and then we'll stop there. We can do B tomorrow, and then tomorrow will be all review of yesterday and today. I think today is a little easier. Just my opinion. Okay, this one has two things happening. It's got adding and subtracting inside, and it's got adding or subtracting outside. But they're not asking us to describe the transformations this time. They don't say compare each graph to the original. It doesn't say that. So we don't have to do that part. All we have to do is graph it and then do the domain and range. Okay, so what do we set equal to 0 this time to find my middle value? Yeah? Someone remind me, what does step 1 say? Take what's where? Yeah? Inside the absolute value bars. So what's inside the absolute value bars? Yep. What is it? More than that. X plus 2. So take everything that's inside the bars and set it equal to what number? Yep. Yep, good. Set it equal to 0. Now, this time we have something we need to do. We need to solve this to get the middle value. How do we solve that for x? Yeah?
Subtract 2 on both sides.
Subtract 2 on both sides. So that's gone. And what do we get for our middle value?
-2.
-2. Perfect. -2 is going to go in the middle. Now we're going to pick 2 lower and 2 higher. What's lower than -2? Yeah? That's higher. But we're going to do that one. Yep. Yep, -3. And what's lower than -3? Yep. -4. Okay, Michael already gave us one that's higher, so that's good. You got that one. I need one more that's higher. Yep. 0. All right, now, when we plug these numbers in, one at a time, we're going to do 3 things. We're going to add 2 to it, then take the absolute value, then -4. Let's start with -4. What's -4 plus 2? So -4 plus 2. Yep. -2. And what's the absolute value of -2? 2. And what's 2 minus 4? -2. There we go. There's our first one. Okay. Next one is -3. What's -3 plus 2? Yeah.
-1.
-1. What's the absolute value of -1?
-3. Wait, no, 1.
1. And then 1 minus 4.
-3.
There's our -3. Let's do -2. What's -2 plus 2? Yeah?
0.
0. What's the absolute value of 0?
0. And
0.
then -4.
And then -4 is -4. Let's do -1. Brady, what's -1 plus 2? 1. What's the absolute value of 1? 1. And what's 1 minus 4? I can't hear you, sorry. Say it again. -3. Yep. So we get -3. What's our last one going to be? Yeah?
-2.
-2. So we've got all our points. And what do I do with all those points?
Oh, graph them.
Graph them. So -4 and -2. I haven't asked you guys yet. Somebody tell me, how do I graph -4 and -2? Left 4, down 2. Perfect. How about -3, -3? Left 3, down 3. Okay. How about -2, -4? Yep. Left 2, down 4. Looking pretty good. -1, -3. How do I do that one? Sean? Left 1, down 3. Left 1. Perfect. And how about 0, -2? Yeah. Just down 2. Okay. Now, draw your V shape. Yeah. And like that. Okay, so they wanted us to do what? Graph it. Okay, we did that. Now describe the domain and the range. Okay, what's the domain? Yep. All real numbers. Now, how about the range? Okay, we're looking up and down. Yeah. -4 and up. So that's every number that's greater than or equal to -4. Okay. Any questions on that? Right, so we'll finish the last one tomorrow. Okay, so homework tonight is worksheet 3.7, and that is on school year. Yeah, I think we got through enough of it. You should be able to do that one for tomorrow. Okay, and just a reminder, I will be after school on Thursday.
Okay.